Okay, so working through question 85, part C in worksheet 10.5. They give us our initial concentration is 0.1 molar and the Ka is this value. So initially we have 0 of our two products, so we will lose X from our reactant and we'll gain the same amount for each product, which gives us at equilibrium this statement. And now we're going to go through and we're going to figure out what the Ka equals. So Ka equals x squared over 0.10 minus x. So now I'm going to have to go through and do the quadratic. And I'm going to multiply this by 0.10 minus x. So now I have to distribute the 2.3 times 10 to the negative third to each. And I get 2.3 times 10 to the negative fourth minus 2.3 times 10 to the negative 2 times x. I need everything on the same side of the equation, so I'm going to move them all to the right-hand side. And so I get that 0 is equal to x squared. And since I'm moving this over, it becomes positive 2.3 times 10 to the negative third x. Since this is positive, over here it will be negative 2.3 times 10 to the negative fourth. Now I'm going to use my quadratic formula, and x squared is a, this term is b, and this one's c. And so I'm going to substitute them in, and I've done that here. And you have to remember that this term is negative. If you don't, and you try and do this math under the square root sign, you'll get an error message. So I went through and I squared this and then I multiplied this out. I was having trouble with my calculation skills. And since this is negative and this is negative, it becomes positive here. And then I can do the rest of the math. And I got two answers. The first was 0.014 molar, and the other one became negative because if I subtract a negative number minus a negative number, I get a negative number. And this one has no physical significance because our molarity cannot be 0 or below 0 or a negative number. So I'm going to go forward with this value. So my initial now for HTE minus 1 is going to be 0.014 molar. But this is also going to be 0.014 molar. And I've written down the Ka for this problem. So now we're ready to go on and do ice or rice. So since I have 0 of Te2 minus, I'm going to lose x here. I have to gain x here, and I have to gain x here. And I get 0.014 minus x, 0.014 plus x. So my Ka2 is going to equal 1.6 times 10 to the negative 11th equals x times 0.014 plus x divided by 0.014 minus x. Now I'm going to assume that x is much, much smaller than 0.014. And so that means for both this term and this term, I can cancel it out. And how can I assume that? Because the power of this exponent is so small or so negative that it's not going to affect this number. And so that would give me 1.6 times 10 to the negative 11th is equal to x times 0.014 over 0.014. And so these two terms would cancel out. So x becomes 1.6 times 10 to the negative 11th. And that would be the concentration of Te minus 2. What is the concentration of hydrogen ions going to be? Well, coming back to here, it says that it would be 0.014 plus 1.6 times 10 to the negative 11th. And if you want to do that in your calculator, feel free, but this number is so small that it will not change this number, and so the hydrogen ion concentration is 0.14 molar. And so going back to the original question, it says demonstrate whether or not the second ionization of H2TE can be neglected in the calculation of the concentration of HTE minus in a 0.10 molar solution of H2TE. And we can see that it would not affect this concentration of all. If I took this number and subtracted this number from it, it would not affect that number at all. So we have confirmed that it doesn't change the concentration. So let me know if you have any other questions. I think that should cover this one at least for now. Thanks. Bye.